Hello everyone, welcome back to chapter 11a. Today we're gonna keep doing the calculus, the integral, and today we're gonna learn what's the sine area and also what is the total area means. So sine area actually is it depends on the x-axis. So if you're above the x-axis, that means a positive. If you below the x-axis, that means a negative. So we can say A1 is a triangle area. So we can say that's pretty much around from 3 times 3 divided by 2, and that's 4.5. And A2 is another one, which is a half. But the thing is, if you calculate the total area, it totally is around like A1 plus A2. But if you want to say the sine area, you have to be A1 minus the A2 because that's a minus degree in the below x-axis. So positive sine area and a negative sine area, we can say A1, A3 is positive and A2, A4 is negative. So for continuous function integral is we can say the definite integrals. So we have the range in between. This is pretty much very interesting things is the sine area in the integral. So let's start with some example one. I might just doing question B and question C. So I leave the question A for during the class and sorry guys, that was the some like emergency call I made it before. Okay, let's start with the question B. First question, let's start with 4, 0 and e to the 2x plus 1 dx. Now we can start doing this e to the 2x again. So if you want to do integral with e to the 2x dx, we can remember e is 2 is your k, so 1 over k, and remember you have to do with your graph as well, so and plus 1 dx as well. So we can rewrite 1 over 2 e to the 2x plus x from 4 to 0. And once we know that, so 1 over k e to the 2 e to the kx and the plus x, we substitution into the 4. So first thing first, half e to the 4 times 2 plus 4 minus, use the bracket please, and 0 plus 0. Oh, actually, the first one not equal to 0, which is we change that one to half e to the 0. Yep, perfect. And then that equal to half e to the 8 plus 4 and minus half. And then that equal to half e to the 8 and then plus 7 over 2. Yep, that's the answer. Question C, we can say is 2 to the x to the half plus e to the half x dx. So we do that one with 4 to 1 and then x to the half plus e to the x over 2 dx. All right. First thing first, as always, we start to write down our integral first, and then we can do the anti-differentiation. For 1 to, actually we can leave the 2 outside, x to the half, and plus for 1 e to the half x dx. Alright, then what we do is, so x to the 3 over 2 because it plus 1, and also 4 over 3 because it times 2, so which is, if I rewrite, we can say 2 times 2 over 3, and then plus 2 times e to the 2 half x. and equal to 4 to 1. So that equal to 4 over 3, 4 to the 3 over 2 plus 2e squared minus 4 over 3 and plus 2e to the half. Yep, and that's the total answer. And now what we do is 4 over 3. And because 4 squared is 16, so what we do is 4 cubed equal to 64. So square root of 64 and plus 2e2 minus 4 over 3 minus 2e half. So, and that equal to 28 over, sorry, not 28, 32 over 3 and plus 2e2 minus 4 over 3 minus 2e half. And that equal to 28 over 3 and plus 2e2 minus 2e half. You could simplify that as well, but I just leave that one. And you could just use the 2, take the common factor, and that's it. That's pretty much all you need to know. Example 2. So I'm gonna do question B, and we leave the question A for us to think about. Now we're gonna do a quick logarithm. So 5, 4, 2x minus 5 dx. So what we do is, so we start with that equal to half outside log e to the 2x minus 5. And remember it's 5 to 4. So that equal to half log e 5 minus half log e to the 3. And then because it's between, which is half log e 5 over 3. And that's the answer. Yeah. So you can see it's clearly it just copy the between is a minus. Okay, so do not write down the plus, and also make sure you remember the rules from A and B and C, chapter 11. So that's basically we follow the rule by any bound reference. Yep, hopefully that's understandable, and I'll see you guys next time.